Okay, hi everybody. Hope you're having a good day. Hope you have a great weekend. Happy Valentine's Day. Let's get out our notes, 5-1, and here we go. It says no calculator. I'm not exactly sure what we would do with a calculator until we get to like number 3 or so. But anyhow, no calculator, here we go. Number 1, A and B are review questions. We know that the tangent is 3/4, and we know that the sine is greater than 0. That kind of got cut off. That's greater than 0. If you do not like theta as your variable, feel free to change it in any of the problems as we go through. If you would rather make it an x, that's fine. Theta's on the paper. I'm going to use theta, but as is the case with all variables, the letter you choose doesn't really matter. Okay, here we go. Where is the tangent a positive number? Now, you should know this because tangent is y over x. And if that's going to be positive, then don't both opposite and adjacent need to be positive, or y and x both positive, or y and x both negative. So for this part of the problem, we are either here or we are here. Now, it says that the sine is positive. Well, remember, sine is associated with y. Is y positive here? Y opposite positive? Is y positive here? No. So that triangle isn't going to work with the second half of the problem, so therefore that's our picture. We want to know what the sine of that picture is. So we'll do our Pythagorean theorem. And that's going to work out to be 16 plus 9. That's going to be 25. So this is 5. The question is, what's the sine of the angle? Opposite over hypotenuse. The sine is 3/5. Okay? Next one, same thing. These are review. This is what we were doing in chapter 4, this kind of thing. All right, so we know that I need sine and cosine. Sorry, I didn't read my problem carefully. So the sine is 3/5 and the cosine is 4/5. Find the sine and the cosine. There they are. Okay, sorry about that. All right, cosine is 4/5 and the tangent is negative. All right, let's start with this. Where is the cosine 4/5? That would be x over r, or adjacent over hypotenuse. So certainly that would be positive here, 4, 5. That would be absolutely okay. Where else is the cosine positive? Well, since cosine is x, it will be right down here. We could have this triangle, or we could have this triangle. All right, now let's look over here. The tangent has to be negative. So you've already narrowed it down. This narrows it down to one of these two quadrants. Cosine is x. X is positive over here. Now tangent needs to be negative. Well, wait a minute, guys. This is quadrant 1. Is anything negative in quadrant 1? No. So it's not this quadrant, it must be this one. So this is the picture we're going to draw. Quadrant 4, adjacent over hypotenuse, x over r is 4/5. So I'm going to do my Pythagorean theorem. This time it's going to be 4 squared plus a squared equals 5 squared. And it's actually a triangle very similar to that. This is going to end up being -3. Because I'm going to have a squared equals 25 minus 16, which is 9. The square root of 9 is 3. Why did I make it negative? Because it's down in quadrant 4. And opposite y is negative in quadrant 4. So, what am I looking for? I want to know the sine and the tangent. So the sine of that angle is -3/5, and the tangent of that angle is -3/4, opposite over adjacent. That is review. All right, now comes the new stuff, which at first might seem hard. Trust me, we'll get through it. You are going to need your reference sheet though. You are allowed to write anything I tell you you can write on this reference sheet. Nothing else. All right, so you can't like write down problems and do problems, whatever, but I'm going to give you maybe some additional things to add to this reference sheet. So this should be sitting right next to you as we move on to problem number 2. All of these problems are different. They're kind of like proofs in geometry. They can be done lots of different ways. Some ways are shorter than other ways. You just have to power through, all right? Directions say simplify. Tangent times cosine. The first thing I'm going to ask you to add, if you wish, you don't have to add anything to your sheet, but if you wish, you can add the fact that the tangent is the sine over the cosine. Now, you might not even have to add that because you already know, hopefully, that tangent is y over x. And y is associated with sine, x is associated with cosine, so tangent is y over x, sine over cosine. But you can add that to your sheet. So when I see this tangent, I'm going to write it as sine over cosine. Now I am multiplying it by cosine. To help me, I'm going to make that cosine over 1. Kids, that doesn't change anything. Putting it over 1 is the same thing, but now things are lined up so that I can see I'm multiplying fractions. Well, luckily, I can actually cancel. So the direction said simplify. That simplifies into sine. How did I do that? I rewrote the tangent. I rewrote the tangent in a way that I can. That's another way of thinking about tangent. All right, let's try B. All right, now let's think about this for a minute. Let's look at our sheet, our reference sheet. You don't have to write anything. This one is right there. Look at it. Do you see on that sheet 1 plus tangent squared anywhere? Why, you do. 1 plus tangent squared is secant squared. Written right on the paper, it says this, guys. So every time you see 1 plus tangent squared, like you see right here, you can replace it with secant squared. It's like substitution. You're substituting in what it is equal to. So this becomes secant squared over cosecant squared. Now things can get a little crazy here. So go with me. Would you agree that that is secant squared divided by cosecant squared? Yes. Now, what is secant squared? Well, it's not written on your paper. It should be stored in your memory already. But if it's not, you can add this to your sheet. Secant is 1 over cosine. And while we're at it, cosecant is 1 over sine. Guys, you know this already. We've been talking about it since Christmas. We've been talking about the fact that secant is reciprocal of cosine and cosecant is reciprocal of sine. Reciprocal, 1 over. But you can add these to your sheet if you wish. So now I've got secant squared. Secant is 1 over cosine. So secant squared will be 1 over cosine squared. I identity, these are called identities or formulas, that isn't going to change. You just put in the squared. So this is 1 over cosine squared divided by 1 over sine squared. Now, how do I divide fractions? This is a fraction divided by a fraction. Keep change flip. So 1 over cosine squared times sine squared over 1. Nothing cancels. Over here somewhere, we had a problem where stuff canceled. Nothing cancels. I'm just going to multiply. So this is going to leave me with sine squared over cosine squared. Sine squared over cosine squared. Whoa, what's that? You wrote it on your sheet. What is sine over cosine? Sine over cosine is tangent. So this becomes tangent squared. Because they're squared, this becomes tangent squared. Now, it just occurred to me that I might need to clarify something. When we square a trigonometric function, like I say tangent squared, we can't write it this way. Would you agree with that? That would be the tangent of x squared. If I want tangent to be squared, I would either have to put it in parentheses. This means tangent squared. Or what we do instead, so that we don't have to keep writing the parentheses, we put the squared after the tangent. Now, every single one of these problems, I guarantee, I don't remember for sure, but I am positive, I haven't said tangent squared x. I just said tangent squared. When you write it on your paper, it has to have an x, or a theta, or a q, whatever letter you're using, whatever variable you're using, the function, tangent, sine, cosine, must have an x attached to it. If it's squared, the squared is going to go on the function, not on the x, so that I don't have to put parentheses, okay? All right, so we clarified that. All right, let's try the next one. I need somebody to remind you, or remind me, one of you guys remind me next time I see you, to tell you the story about the tattoo. That's all you need to tell me. I'll know exactly what you're talking about, but I might forget. So I don't want to do it on video. I want to do it in person because it's really cool, but I need you to remind me, okay? All right, here we go. Let's look on our paper. This paper seems to be kind of magical, very, very useful. Let's look on the paper. Do you see anything about sine squared plus cosine squared? I hope you do. It's kind of a big important one. It's right over here. It says sine squared theta plus cosine squared theta is 1. Now, theta can be anything. These are called identities because they're true no matter what you put here. This could be sine squared p, cosine squared p. In this case, it happens to be sine squared negative x. Doesn't matter one bit. Anytime you have sine squared plus cosine squared, the answer is going to be 1. Sine squared plus cosine squared is 1. The variable doesn't matter. Negative x, 2050 degrees, doesn't matter. Sine squared plus cosine squared is always going to be 1. Done. Easy. All right, let's try this one. Now, I wish you were here so you could give me some ideas about what you're thinking about maybe doing. Is anyone anyone thinking about maybe distributing? This is a distributive situation. So I'll go ahead and distribute. So I have sine x tangent x plus sine x cotangent x. Just distributed sign, like a regular number. Now, what do we know about tangent? Oh, that's right. Tangent is sine over cosine. So I need to multiply these two together. This is a fraction. This is sine over cosine. Sine is just sine. Sine and cosine don't get rewritten. They're like the building blocks. Everything else can be rewritten. Like tangent can be rewritten as sine over cosine. So that's the first part of the problem. Now, plus another sine, and then cotangent. Now, that one's not written on your paper. You might want to write it. You don't have to write it. What do we know about cotangent? Cotangent is the reciprocal of the tangent. If the tangent is sine over cosine, then what is the cotangent? Cosine over sine. So if you want to add that to your sheet, you absolutely can. Cotangent is cosine over sine. If you want to add that. So I'm going to make this right here. I'm going to make that cosine over sine. All right, let's see what we got. Now, this plus sign breaks the problem into two pieces. So we're not going to cancel things over here with things over here. We can cancel anything we want here. Well, guess what? Nothing cancels. It's sine squared over cosine, multiplying. Now here, we can cancel, so we just have cosine over 1. All right, so let's back up and make sure you follow the steps because they're all things you already know how to do. You know how to distribute. With your cheat sheet, you know what tangent can be rewritten as sine over cosine and cotangent cosine over sine. Then we can simplify. Nothing cancels here, so it's sine times sine over cosine. Here we can cancel the sines and we're left with cosine over 1. Now, again, you are not stuck and you are not confused because you're trying to add two fractions. How do you add fractions? You get a common denominator. So this one's cosine, this one's 1. So I am going to multiply this one by a cosine. So now my denominators match. My denominators are both cosine. So I write it down. Don't lose it. Keep it. Keep the denominator. Now what's in the numerator? Sine squared plus cosine squared. We just had a problem with that. What is sine squared plus cosine squared? 1. So this is 1 over cosine. Wait a minute. I had you add it to your sheet if you don't have it memorized. What's 1 over cosine? 1 over cosine is secant. And there is your answer. Remember what your job was. Your job was to take the original problem, which was this mess right here, and simplify it. And it took a few steps, none of which is hard, none of which is something you don't know how to do. You know how to do every single one of those things if you have this sheet with you to help you. Gotta admit, it's pretty cool, guys. Let's see what we have next. This next problem is a perfect example of how there are lots of ways to approach problems. So I'm going to do it what I think is the quickest way, because most of you, that's what you want to do, the fastest way. But again, there are other ways ways to approach the problem. And if you ever do one and you want me to look at it to see if it's right, bring it into me and I'll check it over for you. I happen to love these kind of problems, so I would welcome that. All right, so here we go. The denominator is a no-brainer, you guys. Third time we've talked about it in this video alone. Sine squared plus cosine squared is always 1. So this is 1. So I really just have secant squared minus tangent squared. Agreed? Now, I want you to look at your paper. You will not see this exact thing, but you should see something, some equation, some identity that is tying together secant squareds and tangent squareds. Can you find that identity on your paper? It's tying these two together. You have one that says 1 plus tangent squared is secant squared. That's what's written on your paper. Now, what does that mean? That means that when you see a secant squared, since secant squared equals this, that can replace secant squared. That is the same as secant squared. So I am going to cut this out and paste it right there. So I'm going to have 1 plus tangent squared, and I got to use the right variable, v, minus tangent squared. Oh my goodness gracious. What's going to happen? The answer to this problem is 1. Just 1. So this big ugly mess simplified down to be 1. All right, 2 more. That's all we got of this kind, then we're going to move on to a different kind of problem. But 2 more of these. All right, so let's see what we've got. 1 over sine squared plus secant squared over tangent squared. Again, there are lots of ways that you can do this problem. For me, sines and cosines are like the basics, okay? And so I like to work, if I can, in terms of sines and cosines when I have a problem that has this many functions in it. Okay, there's a lot going on in this problem. So I'm going to leave this guy alone for a moment. And I'm going to see what happens over here. Now keep in mind, this is secant squared divided by tangent squared. That's what this says. Secant squared divided by tangent squared. Not plus, not minus. I really don't want to do this because that's going to introduce more mess into the problem. I want to simplify this. So what do I know about secant squared? I'm just working on this fraction right here. What do I know about secant squared? It's 1 over cosine squared. Divided by, what's this? Sine squared over cosine squared. Now, this is a division problem. So when I have this fraction divided by this fraction, I am going to keep change flip. And what happens when I keep change flip? I have 1 over sine squared Now remember, I had the original 1 over sine squared from the original problem. And now I have simplified this, cleaned this up, and I have another 1 over sine squared. What's 1 over sine squared? Look on your paper, you wrote it down, or you have it memorized. Hopefully you have this one memorized. 1 over sine squared is cosecant squared. So don't I have a cosecant squared plus another cosecant squared? And that's going to make 2 cosecant squared as my answer. Okay. All right, one more. And I seem to remember that I made a mistake in this problem. So I think I'm going to have you can't cross that one off. I remember I made a mistake in this one, and it doesn't really go anywhere. And I will give you problems that go somewhere. So let's cross that one off. Cross off G. I made a mistake when I wrote it. Okay, number 3, part 3. Now we are going to solve, all right? Now these are going to be no calculator problems, but at some point we will get to some calculator problems, all right? But not right now. Right now we're going to solve these without a calculator. Okay, let's look at it. And I notice that these are the directions. So what does that tell me? That tells me that my answers are going to be in degrees. So my answers are going to be things like 30 or 90 or something like that, degrees. When we get down to part 4, we'll do exactly the same process, but we will answer in radians. Okay, let's take a look at this equation. Does anyone notice that it's factorable? That I can factor out a GCF? I can factor out a cosine? And I will be left with 2 sine minus 1. Does anyone notice that? Now, when I factor, think about regular factoring, like with numbers. After you factor something, okay, you get something like this, then don't you set both of these equal to 0? Okay, so I'm going to set both of my things equal to 0. I'm going to say cosine x equals 0, and 2 sine x minus 1 equals 0. You have done this in chapter 4. Not both at the same time. They were separate problems, but you've done this. All right, zeros. You know where we find zeros. We do not find zeros in a triangle. We find zeros somewhere on our circle. Now I'm in degrees, so I'm going to label these in degrees. Where on the circle is cosine 0? Now remember, cosine is x. So I need to look around the circle and find any place or places where the x coordinate, that is the cosine, the x coordinate is 0. All right, where does that happen? Right here and right here. So this first part of the problem, that guy right there, the answers are x equals 90 or 270. So this is going to have answers and this is going to have answers. So we're going to have a lot of answers to the problem. So far we have found where cosine is 0 here and here. Not here, not here, just here and here. Those are the 2 answers we got so far. All right, now let's solve this one. If we add 1 and divide by 2, this one says sine equals 1/2. Let's think about it. Where does that happen? This will be a triangle, and it'll be a triangle in quadrant 1. Sine is 1/2. Or where else? Where else is the sign positive? Over here? This is for it. How do you know that? Because sine is y, and y is positive up here. All right. This is a special triangle. If I'm doing it without a calculator, it's going to be special. And I know that across from the 1 is 30 degrees. So my answers, are this green angle right here, which is 30. And then my purple angle, which is what? Figure that out. Don't just wait for me to do it. You know this. Use your head. You know this is 180. So what angle is that? 150. 180 minus 30. So we have 4 answers to the problem. Original 90 and 270, and then we got 30 and 150. All of those are answers to this problem. I know, it's a lot, but you're capable. You got it. You can do it. I'm 100% confident in you. All right, let's look at the next one. Same directions, so we're still answering in degrees. And I hope you see we're going to do the same thing. Can't we factor? What can we factor? We can take out a tangent. So if we do that, if we take out a tangent, what will we be left with? Root 2 cosine minus 1. I'm taking out my tangent. All right, so what do we do now? Look back at the last one. What do? We set them equal to 0. So tan x equals 0, and root 2 cosine minus 1 equals 0. Now, zeros, remember, you can't have a triangle with a side of 0, okay? Not possible. So, we're going to have to look at our circle. Okay? Now, remember, tangent is y over x. And we need y over x to be equal to 0. So I'm going to make that 0 over 1. So I need to look around the circle. Where do I put y over x and get 0? Doesn't it happen right here? Y over x? So one of my answers is 0 again. This is 0 degrees. So one of my answers is 0 degrees. What happens here? If I put y over x, do I get 0? No, I get undefined. All right, what about here? If I put y over x, I get 0 again, so that's 180. How about down here? Nope, undefined. Remember, you're doing a tangent problem, and tangent is y over x. Okay, all right. Now, what about this part? Well, this is going to say cosine equals 1 over root 2 if I add 1 and divide by root 2. So that's going to be a triangle. Where? Well, certainly quadrant 1. 1 over root 2. Oops. Where else? It's cosine. Cosine is x. X is positive here on the right. So how big an angle do I have here? If the cosine, oh my gosh, cosine adjacent over hypotenuse. Not that it matters, because this is also a 1, but cosine is adjacent over hypotenuse. So what kind of angle is that? 45. This one's also 45. In the same problem, in the same picture here, your angles are going to always match. Okay, you're not going to have a separate angle that's different. So what are my answers? Well, remember, this is where I start, right here. So one of my answers is 45 degrees. What is another answer? Well, the other answer would be all the way around to here. How big is that one? Use your head. If you said 315, you are right. How did we get 315? Kids, all the way around is 360. I went all the way around except for this 45. So 360 minus 45, 315. And there you go. Those are the answers to the question. All right, we're going to do a couple more. Hang on. Remember, if you get, the beauty of video is you can shut me off, or you can stop and replay and hear it all again. All right. Next problem, the directions change. It's exactly the same kind of problem, but the directions have changed. So this tells me that now all of my answers will be in radians. So I won't say 90, for example. I'll have to say pi over 2. Okay? Otherwise, everything I do is going to be exactly the same as what I just did. But Mrs. Ford, this first problem looks different. Well, it really isn't different. What did I do? What did I do when I wrote the problem down? I got it set equal to 0, because I always want my problems to be set equal to 0. Okay, kids? If you were thinking when you looked at this, oh, I'll divide by tangent, don't. You can't. You have to set it equal to 0. And once you get it set equal to 0, then you can factor. So I'm going to factor out a tangent. Now, what do I have left? Sine squared minus 1. So I need tangent to equal 0. And I need sine squared to equal 1. I need this to equal 0, so add 1. Sine squared equals 1. I think I just did this, actually. That's a 0. I'll do it again. That's a 0. And zeros are always around the circle. So I'm going to look around the circle. I'm going to remember that tangent is y over x. So y over x, does that give me 0? Yes, it does. 0 over 1 is 0. So that's one of my answers, 0 degrees, or 0 radians, I'm sorry. I'm in radians, and at 0, it doesn't matter. That's 0, period. Okay, what about here? Is 1 over 0, y over x, 0? Nope, undefined. Throw it out. How about over here? Is 0 over negative 1, y over x, is that equal to 0? Yep. So my next answer is pi. Last time it was 180 because of the directions. Now it's pi. Down here, nope, not going to work. Negative 1, 0. Negative 1 over 0 isn't going to work. All right, so there you go. There are the answers to where the tangent is 0. Now, this guy, I have to square root both sides. So sine is going to equal plus or minus, when I square root, I have to do plus or minus, the square root of 1, which is 1. You could also, I don't know if you thought about this, but this factors into sine x plus 1, sine x minus 1, so you could do that also. And notice when you set these equal to 0, this one says sine x equals -1, and this one says sine x equals +1. So if you would rather factor, I think it's quicker to take the square root, but do whatever you want. This is what you're going to come up with. Now, where is the sine? That is y. Where is y +1? Now let's look around the circle. Y is +1 right here. So the answer to the +1 answer problem, part of the problem, is pi/2. Remember, that's 90, that's half a pi. Now here, I need sine to be -1. This is not sine, this is cosine. Cosine is x. I need sine y to be -1. So that's down here, which is 3 pi/2. Now I'm actually glad that I'm not doing this with you, because at this point you're going to be mad at me, because there's a wrinkle here in this problem, an extra little wrinkle. I want you to think about tangent. This problem, look at the original problem. This problem has tangents and sines in it. And whatever answers I get have to work in the problem. I want you to look at this answer right here, pi/2. If I put pi/2 in right here, I'd have to take the tangent of pi/2. Kids, what is the tangent of pi/2? 1/0, y/x. Isn't it undefined? You can't take the tangent of pi/2. Can you take the tangent of 3 pi/2? Remember, the tangent curve has asymptotes. And wherever it has asymptotes, it doesn't exist. So these are actually extraneous roots. Oh my gosh, how am I going to remember all this? Guys, you need to remember that tangent can be undefined. Sine and cosine are always good. You don't have to worry about sine and cosine. But tangent can be undefined. So if your problem has a tangent in it, you cannot have an answer here or here, because at those two places, the tangent does not exist. Now notice, my last problem that I did and erased, but you can look at it, it had a tangent in it. But my answers were not these. My answers were not 90 and 270. There was something else, and that's fine. The tangent is always fine, except here and here. And yeah, you got to remember that. And no, you don't get to write that on your reference sheet. That does not go on your reference sheet. Okay, that's something that's stored up here. All right, we're going to do one more. And then we're going to be done. Okay, so one more. Here we go. Letter B, 4B. Oh, shoot. This one involves a tangent. That's okay. Tangents are fine as long as your answer isn't 90 or 270. Pi/2, 3 pi/2. Tangents are fine. You just can't have those as your answers. All right, so let's look at what we do have. We have tangent squared equals 3. All right, so what am I going to do? Well, I don't know what you're going to do, but I'm going to do this. There isn't anything to factor. There's nothing, else going on. I'm just going to square root both sides. So what does it say? Tangent x equals plus or minus root 3. Don't forget the plus or minus. When you square root, you got a plus or minus. Now wait, if the tangent can be positive or negative, doesn't that mean it can be anywhere? Because we know the tangent is positive here, because here x and y are both positive, here x and y are both negative. So that would make a positive y over x, positive tangent. And then over here, and down here, you have one positive and one negative. Like this is negative, but this is positive. This is negative, but this is positive. So if you can be either one, positive or negative, then you're everywhere. You can be anywhere. And we want the tangent, I'm going to go ahead and make it a fraction because it's y over x, opposite over adjacent. And I only need to label one triangle because I know the angles are going to be the same. In one problem, all the triangles are going to be the same in one piece of the problem. So if we say tan x equals root 3, they're all going to be the same. So this is 2. Now you need to know how big this angle is right here. That's the key. Well, look at that picture. This is the root 3. So we know that that angle is 60. Now, here's the problem. I have to be in radians. So I remember that 60 is 180 divided by 3. So instead of 60, I'm going to call this pi over 3. 180, pi is 180. A third of 180 is 60. Now, all of these angles, then, are pi over 3. So there are going to be 4 answers. I'll go ahead and do the first one here, this black one here. This angle right here is pi over 3. The first quadrant angle, pi over 3. The second quadrant angle is right here. Now remember, this is pi. This angle is a third of pi. So I didn't make it all the way to pi. I stopped with a third to go. So if I stopped with a third to go, didn't I do 2/3? Didn't I go 2/3 of the way? 2/3 of pi? This angle, this red angle, is pi minus pi over 3. So it's 1 minus a third, 2/3. All right, now I got my pink one. Again, starts here, they all start here. Goes all the way around, past pi, and then another third more. So the pink one is pi plus a third. It goes all the way to pi, and then an additional pi over 3. So the pink one is 4/3. 1 1/3. 4/3. And then what about my purple one? My purple one goes all the way around to here. Now remember, this is 2 pi. All the way around is 2 pi. So if I went all the way around, it would be 2 pi. But I didn't go all the way around. I went all the way around except for pi over 3. So that is 2 pi minus pi over 3. Drop the pi's, it's 2 minus a third. What's 2 minus a third? 5/3. So the other answer is 5/3. That would be the same as doing 360 minus 60. I'm just doing it in radians instead of degrees. A minute ago, a problem had extraneous roots. Does this one? No, because the only time tangent is extraneous is if your answers are pi over 2 or 3 pi over 2. That is not what I have here. So all 4 of these answers are perfectly fine answers to the problem. Okay? All right, I want to do one more thing with you. I know I told you I was done, but I want to do one more. I want you to get your homework out. And I want to do the first problem on the homework with you. I'm not assigning the homework. We're not done yet. You could certainly make a good stab at it, but we haven't finished the notes yet, so I'm not going to assign it. But I want to do the first problem with you, all right? The first problem. So I'm on my homework, and I'm looking at the first problem. And it's one of those simplify ones. So it's not one of these solves. It's one of those that starts really big and ugly. And you're going to simplify it. All right, now I hope you have an idea, because you've seen something like this before. Let's factor out a sine. Now, what is going to happen when I factor out a sine? If I take a sine out of this, I am going to be left with sine squared. This is sine cubed, so this is sine, sine, sine. I'm pulling one out, so I'm left with sine, sine. I'm pulling out the sine, so I'm going to be left with cosine squared. If I pull that out. Wait a minute, what's that? This is like the 4th time just today we've run into that. And what is it? 1. So we have sine times 1. That's just 1. So the answer to the first homework problem is sine. Again, I'm not assigning it. Certainly take a look at it if you wish. I'll try to do a couple, maybe more, another day. I don't know. Who knows? But anyway, that's it. Thanks for watching, and have a great day, great weekend.